Alright, so this will be the first proof that we're doing with corresponding parts of congruent triangles are congruent. Now that we understand that this is a true statement, we can use this CPCTC to prove that two segments are congruent in two different triangles. And to do that, we can also use it to prove two angles are congruent in two different triangles. In this case, it's two segments. To do that, though, we have to first prove two triangles are congruent. So this is just an extension of the previous topic where we had to use two-column proofs to show that two triangles were congruent. We still have to show that two triangles are congruent to be able to use CPCTC to prove that corresponding parts of them are congruent. So we're just adding another step on here. So first, let's look at our givens. We are told that NM, segment NM, is congruent to segment PQ. We're also told, or we're given, that angle N is congruent to angle P. Those are my givens. I know it because I was told it. I was just given to me freely. Now let's mark our figure with our givens. That angle N is congruent to angle P. Segment NM is congruent to segment PQ. Now let me switch colors because now we need to start doing our brainstorming and start trying to figure out how we can get to ML being congruent, segment ML being congruent to segment QL. What's going to let us do that? How will we get there? If we look at what we can tell about this figure right now, I can't say anything about angle M and angle Q. There's nothing that lets me do that. I can't say anything about segment PL or segment NL. And I definitely can't say anything about segment ML and QL. That's what I'm trying to prove. I don't have enough to do anything with that yet. But I can say, in my brainstorming here, that angle NLM, I need two hash marks there, sorry. Angle NLM is congruent to angle PLQ. How do I know that? Well, because we know that vertical angles are congruent. We could say VAC for vertical angles are congruent, or VAT for vertical angle theorem. Either one states the same thing, but that is definitely a true statement. Now let's look at what I have so far. Remember, to be able to prove that these two corresponding segments are congruent, first I need to prove that the triangles that they're in are congruent. Do I have enough at this point? Well, I have a segment, I have an angle, I have an angle. Some people would call that angle, angle, side. I prefer to call it side, angle, angle, because then we get to use the nice little statement that we've proven that these two triangles are congruent by SAW. Anyways, so we got triangle NLM is congruent to triangle PLQ by side, angle, angle. Now once I know that's true, once I know that these two triangles are congruent, I can enter a whole new realm, and so many more things become available to me. I can start saying things like, hey, guess what? NM corresponds to PQ, so that makes sense. Angle N corresponds to angle P, so that makes sense. They should be congruent to each other. These angles are corresponding. Guess what? These angles are corresponding too. Angle M and angle Q. So now I can make statements like, hey, angle M is congruent to angle Q. I know that because corresponding parts of congruent triangles are also congruent. I can make a statement like segment NL is congruent to segment PL. Congruent to segment PL. I know that for the same reason. But the key here, what I'm trying to prove based on the task that I've been given, is that segment ML is congruent to segment QL. And in fact it is. Segment ML is congruent to segment QL because of CPCTC. So now, in my brainstorming and I'm writing things down, I've got myself logically through where I need to go to prove that segment ML is congruent to segment QL. Now I just need to organize it in my two-column proof. In my two-column proof, I need this one. I need this one. I don't need these two. They are true statements, but they're not needed in my proof. If you have them in your proof and they're true statements, you're not going to get it marked wrong, but you need to make sure that you have everything that you need in your proof. I need this, my final proof. So now if I wanted to write my step 2, I could include angle NLM is congruent to angle PLQ. I know that because vertical angles are congruent. You could also write vertical angle theorem, VAT, if you like. And the next thing that I was able to prove or show was that triangle NLM is congruent to triangle PLQ. I was able to show that by side angle angle. And then, what else do I need in here? Once I had that, once I know those two triangles are congruent, I could say that corresponding parts of those triangles are also congruent. Or segment ML, which is what I'm trying to prove, is congruent to, I forgot my line over there, segment QL. Clean this up over here really quick. Segment QL. And we know that because of CPCTC. Now, let's look back up here. How did I know that these vertical angles are congruent? Where did I get this information from? That came from my figure. I was able to look at my figure and determine visually that they were vertical angles. Where did I get side angle angle from? Well, I got one side from the given in step 1. I got one angle from the given in step 1 as well. And I also got the other angle from step 2. So that tells me the side angle angle came from step 1, and step 2. And then my CPCTC, I was able to use step 3 here to state that corresponding parts of congruent triangles are congruent.